Hello and welcome. We're doing a little more advent of code, even though you may notice here that day 10 beat my ass. I decided to come back. Maybe we only do part 1 of day 11, maybe we are able to do part 2 as well, I don't know. But day 10 definitely beat my ass. Alright. Day 11 reactor. You hear some loud beeping coming from a hatch on the floor of the factory. You decide to check it out. Inside you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping. A large toroidal reactor which powers the factory above. Some elves here are hurriedly running between the reactor and nearby server rack, apparently trying to fix something. One of the elves notices you and rush over. It's a good thing you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. Glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs. Each line gives the name of a device, followed by a list of devices to which it has outputs, to which its outputs are attached. So this means that device BB has 2 outputs. The elves are pretty sure the issue isn't due to any specific device, but rather the issue is triggered by data flowing through some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. So it's a directed graph. After dividing up the work, the elves would like you to focus on the devices starting with the one next to you. An elf hastily attaches a label which just says you, and ending with the main output to the reactor, which is device with the label out. To help the elves figure out which path is causing the issue, they need to find every path from you to out. In this example, these are all the paths from you to out. In total, there are 5 different paths leading from you to out. How many different paths lead from you to out? Okay. Okay, cool. That was a what? What is open chat? Ooh. That way is the path of darkness. Did I ever a perfect medal on the games? Did you ever a perfect medal on the game? By the by, Auth, did you ever a perfect medal on the games? By the by, capital A, Auth, did you ever a perfect medal on the games? I don't get it. Have I gotten a perfect in Rhythm Heaven yet? No, I didn't get any perfect medals. I kept getting my ass beat. I think this might work. I don't know. No. That's not gonna, it's just gonna give me the right answer faster. Why one path through CC? Should have been 3 paths through CC. D, E, and F. Doesn't this fall apart if you have a loop, though? I feel like this just doesn't give me an answer if I have a loop. The way I have this implemented. I mean, that's fine. I'll see. Okay. Thanks in part to your analysis, the elves have figured out a little bit about the issue. They now know that the problematic data path passes through both DAC and FFT, a device which performs a fast Fourier transform. A digital analog converter and fast Fourier transform. They're still not sure which specific path is the problem, and so now they need to find every path from SVR to out. However, the paths you find must also visit both DAC and FFT in any order. Okay. Basically, I just want to look at all paths that have both of those in it. I think the acknowledgement this has no loops means there might have been an easier way to solve this with a like a directed acyclic graph. Maybe be able to like topological sort it, or be able to do some basic dynamic programming. I mean, this is dynamic programming. I don't know what I'm talking about. Why is this getting 0? Are none of the paths... I mean, if I set these... What if I just set one of them to true? I get 0. What if I set this one to true? If I set this one to true, then something's just broken. That's... a big number? Why is that number so big? Does the path emanating from you not hit that many... Why is that number so big? Let's try it on this one and see what happens. Only 2 paths hit both of them. It does acknowledge there's 8 paths. That's correct. So... and that gets 0. But then DAC is not getting back to... I think it's because of this. It's because I'm memoizing a wrong solution at that point. getting curious about something. There's 0 paths. There's 1 path there. Yeah, that's interesting. I mean, that's not the right answer. Oh, well. No, thank you. This... So if this is a directed acyclic graph... Well, it's because I turned off all of the memoization at this point, basically. So here's a question. How many routes are there from the server to... I don't care about these pieces here. I mean... certainly this is not going to give me the right answer, right? All the way around. Wait, why did... I literally just generated the 3 numbers I wanted. Right there. What are you doing? Yeah, but if it's a directed graph, then the other order doesn't exist. Like, assuming that all my code isn't completely fucked. If I ask how many paths are there from DAC to FFT, I get 0. And FFT to DAC, I get that many. So I think there is an implicit order. You can't even get from DAC to FFT. Oh, I understand why it's not working. I do not think this is going to give me the right answer. I'm exploring at the moment. Oh, never mind. That was the right answer. Alright, whatever. If you know it's a directed graph, and that it doesn't have cycles, then you know that the solution to the longer problem, which might be intractable to solve, is just the solution to the smaller subproblems multiplied together, so... That's why I was willing to explore that, is because I hadn't proven it was a directed acyclic graph, but it stands to reason that if it were, that would actually work mathematically. I could have proven it didn't have cycles by just running topological sort on it. There's a very simple algorithm for determining whether or not you're dealing with a directed acyclic graph. Here's the algorithm. Run topological sort. If topological sort fails, it's not directed acyclic. Yeah, so like all of this is, it turned out to be unimportant. That's funny. I'm gonna excise it from my code because I don't care about it. But I do care about my code. You might be asking yourself, why are you still modifying your code? Didn't you solve the problem? Shut up. Alright. But what if you solved it a little better? That's true. What if I did? Sadly, that is not the reality I live in. Yeah, I mean, a lot of this stuff is not stuff that you need to know for real-world problems. I would say, generally speaking, if you're dealing with a real-world problem, and, like, you are Like, I'm thinking about it in a scientific context. If you're collecting data and you're like, oh, this is a graph and I'm going to use a graph algorithm to solve it, you already know whether or not it's a directed acyclic graph. You already know certain, you know, intrinsic properties that are going to help you. Like, discerning this information from problem input is like puzzle territory. Does it, like, hint at it being a directed acyclic graph? I mean, it says it flows from one node to another and never flows backwards, but that doesn't say that it's acyclic. I mean, I'd agree with you if it was DAG, but it's not. I don't think DAC was supposed to be the hint. Anyway. I'm just happy that we got it solved reasonably. Alright, well, that's going to be it for Advent of Code today. We're going to move on to Pikmin 2, so see you there.